Hello. In this video we're looking at the second of the two differentiation rules, the product rule, which can be written as y dash equals uv dash plus u dash v. So, as you should already be aware, a product is what you get when you multiply two things together. So if we have two functions of x, u and v, and we know how to differentiate each of them individually, but we want to differentiate the product uv, then we can use the product rule. So if y equals uv, then dy by dx is equal to u dv by dx plus v du by dx, which I tend to write as y dash equals uv dash plus v u dash. So here are some examples. So top left, y equals x sine x. It doesn't matter which one is u and which one is v, so just keep them in order, I guess. If u equals x and v equals sine x, we know that u dash will equal 1, that's du by dx, and v dash will equal cos x. And then the rule says that we multiply u by v dash and v by u dash. So I suppose you could call it some sort of cross multiplication. So uv dash would be x cos x, v u dash would be sine x times 1, and we add them together and we get x cos x plus sine x. Top right, we've got y equals x squared e to the x. So if we let u equal x squared and v equal e to the x, then u dash equals 2x and v dash equals e to the x. So uv dash will be x squared times e to the x. V u dash will be e to the x times 2x, which we would write as 2x e to the x. So we've got x squared e to the x plus 2x e to the x. So that's the answer, but if we wanted to, and this will be useful when we're doing things like tangents and normals and stationary points and stuff, we could factorize it. So both terms have an x e to the x. The first one has an extra x, the second term has an extra 2. So we've got x e to the x, brackets x plus 2. Bottom left, we've got y equals x times the square root of 7x plus 3. And before we start, I've rewritten the square root of 7x plus 3 as 7x plus 3 to the power of a half. And then I'll be able to use the chain rule. So if we let u equal x and v be the square root of 7x plus 3, the differential u dash is 1. Using the chain rule, v dash will be 7 over 2 times 7x plus 3 to the minus a half. I won't show you the chain rule here, but you can use it from before. So that gives us uv dash as 7x over 2 times 7x plus 3 to the minus a half, and vu dash just as 7x plus 3 to the power of a half. And then finally, bottom right, we've got y equals 2x to the 5 ln x. So again, we can let u equal 2x to the 5 and v equal ln x. U dash is 10x to the 4, v dash is 1 over x. And then if we times u by v dash and v by u dash and add them together, we get dy by dx is equal to 2x to the power 4 plus 10x to the power 4 ln x. We're going to look at two examples of the product rule. This is the first, the other one will involve finding the equation of a tangent. So, example, given that y equals, in brackets, 2x plus 3, close brackets, times by 3x minus 8 all to the power of 4, show that y dash is equal to 10, brackets, 3x plus 2 times 3x minus 8 cubed. So let's split that up into a u and a v. So u can be 2x plus 3, and v can be 3x minus 8 all to the power of 4. So we know that u dash will be 2, but we'd need to use the chain rule for v, which will end up by multiplying by the 3 and the 4, which is the index, and reducing the index by 1, which gives us 12 lots of 3x minus 8 cubed. And then we can substitute those things into the product rule. So uv dash is going to be 2x plus 3 times 12 lots of 3x minus 8 cubed, and vu dash will be 2 lots of 3x minus 8 to the power of 4. Now that would normally be acceptable as an answer, but we've been asked to show that dy by dx is something specific. So the first thing I'm going to do is to times the 2x plus 3 by 12. So that gives us 24x plus 36 multiplied by 3x minus 8 cubed. And then since both terms contain a 3x minus 8 cubed, I can then factorize that out. So the first term will leave me with 24x plus 36, and the second term will leave me with a 2 and an extra 3x minus 8. On the next line, I've simply multiplied out the brackets. 2 lots of 3x minus 8 is 6x minus 16. And then collecting like terms, 24x plus 6x is 30x, 36 take 16 is 20. And then simply factorising 30x plus 20 gives us 10 lots of 3x plus 2 multiplied by our 3x minus 8 to the power of 3. And for our second example, we have been asked to find the equation of the tangent of the curve y equals x square root 6x plus 7 when y is greater or equal to 0, when x equals 3, in the form ax plus by plus c equals 0, where a, b, and c are integers. So just like the previous example, first thing I've done is to split it into u and v. So u equals x, v is 6x plus 7 to the power of a half, because it's the square root. U again, we can just differentiate that straight away. U dash equals 1, but for v we need to use the chain rule, and that will give us 3 lots of 6x plus 7 to the minus a half. I suggest that you try that yourselves independently. And now applying the product rule, uv dash is x times 3 lots of 6x plus 7 to the minus a half, which can be rewritten as 3x over the square root of 6x plus 7. Vu dash is 6x plus 7 to the power of half times 1, which is just the square root of 6x plus 7. And then if we add those together, and we can do that by timesing the second term by root 6x plus 7 over itself, we get 3x plus the square of root of 6x plus 7 over the square root of 6x plus 7. The square of the square root of 6x plus 7 is of course just 6x plus 7, so that gives us 9x plus 7 on the numerator, and the square root of 6x plus 7 on the denominator. Now, in order to work out the equation of the tangent, we need to know the value of y when x equals 3 and the value of dy by dx when x equals 3. So I've started off by substituting x equals 3 into the original formula. So y is equal to 3 multiplied by the square root of 6 times 3 plus 7. 6 times 3 plus 7 is 25. Square root of that is 5. We were told in the question that y was always greater than or equal to 0. So 3 times 5, which is 15. And then in a similar way, I'm substituting x equals 3 into our expression for dy by dx. So 9 threes plus 7 will give us 34. We already know that the square root of 6 threes plus 7 is 5. So the gradient is 34 fifths. So using the equation y minus y1 is equal to mx minus x1, we know that y1 is 15, we know that m is 34 fifths, and we were told to use x1 as 3. And then multiplying both sides by 5, expanding the brackets and bringing everything over to the left, because we've been asked to write it in the form ax plus by plus c equals 0, where a, b, and c are integers. We get minus 34x plus 5y plus 27 is equal to 0, which we could, of course, have written as 34x minus 5y minus 27 is equal to 0.